Very good morning, guys. Very good morning. Today we are in the lecture 28 of Environmental Engineering 2 in Unit 3. Today's topic is the chemical characteristics in water wastewater treatment. Right? So in the last class we have discussed about the various types of sewage characteristics. That is physical characteristics, chemical characteristics, and biological characteristics. So in this physical characteristics you have seen, the various things like temperature, odor, right, the color, and the so I think this figure will be till the end of your unit 3, right? Okay, so this is a wastewater management. So keep this figure in your mind, right? So how the process is going on and how it is coming to the treatment plant, and later how it is going to the other areas. Next. So this is the real picture of a wastewater management setup. So in the last class we have discussed about these three things generally, and we have involved the waste topics like turbidity, color, odor, temperature, and in the chemical characteristics we have to discuss balance topics in this chemical characteristics, and in the bacterial or biological characteristics we have to discuss the balance things, right? So I think hope today 4 students. Sudhakar is a new person. Sheikh Abdul Wahab. Yeah, waiting for some more positively. Yes. So for the new students or fresh students, so we are in the unit 3. So we are discussing here the wastewater quality. So before going for treatment, what are the things we are having in the physical characteristics? What are the things we are having in the chemical characteristics? What are the things we are having in the biological characteristics? Okay, right. Yeah. So in this type of physical characteristics, we are having 4 types, that is turbidity, color, odor, and temperature, right? So we will discuss that in a brief. The physical properties like color, we have to see the color of the water. So domestic and industrial waste, natural decay of organic material. So based upon this category, the color of the water will be changing. It may be black water, or it may be brown water, or it may be green water, or it may be yellow water. Then odor, smell, decomposing of wastewater, industrial waste. So how the water is decomposing? So yesterday's class lo cheptunnam, your example at your roadside or your inti pakkana oka water pond atane stagnate ayyi water inkakunda waste papers, covers, algae పాచి అంతా చేరుకుపోయి the water will not get evaporated. So at that time what happens, whatever the chemicals, whatever the other materials, toxic materials forming on this water, finally it will give some decomposing wastewater smell. And also if you see the industrial waste, hey Kanika, shit. If you see the industrial wastewater also, here also you can see depends upon the factory or what they are getting, what they are manufacturing. For example, if you see the garments factory, అంటే బట్టలు తయారు చేసే కంపెనీ, లేదంటే పెస్టిసైడ్స్ తయారు చేసే కంపెనీ, if you go near to the company అంటే just around the roadside అక్కడికి వెళ్ళినా కూడా some sort of smell you can observe, some sort of bad smell or some sort of toxic smell, some sort of confusing smell. So these are the things you are getting as a order. Next, solids. So here the domestic water supply, domestic and industrial waste, soil erosion, inflow infiltration. So these are the solids which are suspended or which are dissolved. Next, temperature. So the temperature of domestic and industrial wastewater. So generally the wastewater, sewage wastewater will be normally at higher temperature when compared to the normal inflow water. Why? Because the chemicals or whatever the organic materials or decomposition takes place. Because of that reason, some of the generally the sewage wastewater will be in higher temperature when compared to the normal inflow water. So, and also the example has been given in Indian countries, we are having about 200 degrees centigrade. Next, chemical characteristics. So, chemical characteristics. So, we have discussed about the various carbohydrates, organic materials, fat, oils, and grease. What we have discussed in the last topic stopped there. The domestic, commercial, industrial waste, pesticides coming from the agriculture, the whatever the pesticides, chemicals, right? Pesticides, chemicals coming from the agriculture waste. Next, phenols. What are the chemicals used for the manufacturing of plastic things you are using? That is also a chemical industrial waste. Next, proteins. These are the domestic, commercial, and industrial waste that are coming from these sources. Next, priority pollutants. These are also we are getting from the domestic, commercial, and industrial waste. Next, surfactants. Same. Volatile organic compounds, the same source. Others such as organic materials and alkalinity. Also coming from the groundwater, domestic, and industrial waste. Other chemicals like chlorides, heavy metals, chlorides, heavy metals, nitrogen, pH, phosphorus, sulfur, gases, hydrosulfide gas, methane gas, oxygen gas. So these things we are getting from domestic waste, right? So these are the chemical characteristics what which we have to study in detail, right? The total suspended solids, these are 99%, 99.9% of water, only 0.1% of solids. Then what about the solids? The solids are of various types. Depends upon their application and depends upon the size. So you are having suspended solids, we are having colloidal solids, we are having dissolved solids, we are having settable solids. So if you see the pH value of this water also, so the main thing pH value, if the pH value is 7, it is neutral. If the pH value is greater than 7, it is alkaline in nature. If the pH value is less than 7, it is acidic in nature. So based upon this also, you have to separate the sewage wastewater based upon this pH value, right? It indicates the negative log of hydrogen ion concentration present in the sewage water, right? Next. So this is the instrument. This is the instrument where this is used for checking the pH value. So you're having two different pH meters. This is an external sensor where you're keeping this probe to the sample and you are having buffer solutions. So these are the solutions and pH probe. So this is a probe. So this is a device where you are using for checking of the pH value, right? Next one is the chlorine content. How much chloride is present in the sewage water? Generally present in municipal sewage derived from kitchen waste, human waste, and urinary discharges. Very high chloride content indicates the presence of industrial waste or infiltration of seawater. Determined by treating the wastewater with the standard silver nitrate solution using potassium chromate as indicator. So, chloride content, we have for checking of this chloride content in the wastewater, we are using standard silver nitrate solution and potassium chromate for the checking of the chloride. Next one is the fats, oils, and greases. So we have discussed this one regarding the where it is coming. So regarding the fats, oils, and greases, if you see in industries, they are coming through the machines or processes or tools. Whereas in the industry, in the kitchens, hotels, and restaurants, it is derived from the animal waste and the vegetable matter. Right? Next. Yeah, we'll start here. The next one is the sulfides, sulfates, and gases. The sulfides and sulfates formed due to the decomposition of sulfur. So sulfur decomposition ainappudu we are getting the sulfides and sulfates. In aerobic digestion, the aerobic and facultative bacteria oxidize the sulfur compounds to form the sulfates. Sulfates ela form avutundi in the aerobic environment lo. Aerobic ante where the oxygen is present, right? The bacteria oxidizes with the sulfur, forming the sulfates. The bacteria anedi sulfur ki add ayyi we are getting the sulfates, which is the stable unobjectionable end product, right? Next, in anaerobic digestion, anaerobic and facultative bacteria reduce the sulfurous matter into sulfides. So in the absence of oxygen area low, whenever the bacteria is reducing the sulfurous matter into sulfides with the evolution of H2S gas, hydrogen sulfide gas, along with the carbon dioxide and the CH4 methane, causing obnoxious odors. So these are very dangerous for the aquatic animals as well as the human. So that's why we have to reduce the sulfides and sulfates and H2 gases in the sewage water, right? So these are based on the aerobic digestion and anaerobic digestion. Next one is the dissolved oxygen. The next one is dissolved oxygen. So these are the oximeter with an electrode in the calibration vessel. So these are the solutions. These are the cleaning solutions for cathode cleaner and other new material. This is a probe where you are checking for the oximeter level, how much amount of oxygen is present in the water. Now, seeing the dissolved oxygen, determination of dissolved oxygen is very, very important. Necessary to ensure that 4 ppm of dissolved oxygen means 4 points per million, right? Dissolved oxygen in the river streams while discharging the treated sewage. Actual quantity of dissolved oxygen is governed by the first one is solubility of oxygen. How much amount of oxygen is dissolved in the sewage wastewater. Second one, partial pressure of oxygen in the atmosphere. So partial pressure of oxygen. So how much pressure of oxygen is present in the atmosphere? Third one, the temperature. So what is the temperature range in the what is the temperature of a sewage wastewater? Sewage water. What is the temperature of the sewage water? Sewage water when there is a changes in the oxygen levels. So oxygen levels change outunnappudu the temperature also gets changed. Next one is the purity of water. So we have to check the purity of water based upon the dissolved oxygen in the sewage water. The next one, dissolved oxygen of wastewater decreases. Dissolved oxygen of wastewater decreases as the temperature is increased. So when the temperature is keep on increasing, dissolved oxygen is keep on reducing. The dissolved oxygen is determined by using Winkler's method. It is used by using the Winkler's method. So these topics are not going in very depth, because if you get any question, what are the physical characteristics of sewage wastewater అన్నప్పుడు ఆ 4 points, ఆ 4 types రాసి దాని లోపల 3 or 4 points. What are the chemical characteristics of sewage water అన్నప్పుడు ఈ మెయిన్ హెడ్డింగ్స్ రాసి దాని లోపల 1-2 points రాయండి. So if the Winkler's method and other methods what you are getting, so these are not in depthly they will ask. Okay, don't get confused about that. Okay, so ఇప్పుడు మనం ఏం చెప్పుకున్నాము, the chemical characteristics, the main topics. See the main topics. These are the main topics. So if you get a question, you will get a question like this. So these are the chemical characteristics where headings రాసుకోవాలి. So explain the chemical characteristics of sewage wastewater అన్నప్పుడు ఈ టాపిక్స్ రాస్తే దీని మీద 1 or 2 points రాయాలి. Explain the physical characteristics of sewage wastewater అన్నప్పుడు you have to write these 4 topics and you have to write 3 or 4 points. Explain the bacteriobiological characteristics అన్నప్పుడు we have to write these points and we have to close the question. So depends upon the question, depends upon what they are asking, you have to write the concept. Okay, don't get confused regarding that. Next one. Next, how to measure the organic matter? How to measure the organic matter present in the chemical sewage water? So we are having many parameters used to measure the concentration of the organic matter present in the wastewater. So the first one is biological oxygen demand. The first one is biochemical oxygen demand, that is BOD. The second one is the chemical oxygen demand, that is COD. Next one is total organic carbon, TOC. Next one is the theoretical oxygen, that is PHOD. These are the four parameters where you are checking the concentration of organic matter in the sewage water, right? BOD, COD, TOC and THOD. So among these four things, ఎక్కువగా మనము యూస్ చేసేది BOD analysis and COD analysis. So we will discuss these things in detail. Okay. Then what? Sorry. So if you see the first thing, the COD analysis, chemical oxygen demand. So what is the meaning of chemical oxygen demand? This is a thing, this is a measuring agent parameter test for the measuring the amount of carbon in organic matter of sewage. So here it will check the carbon content, in organic matter. COD determines the oxygen required for chemical oxidation. COD determines the oxygen required for chemical oxidation of organic matter with the help of strong chemical oxidant. So what they are ensuring here, so these are used for testing the carbon content in the sewage. Thereby, how to determine it? Is used for requiring the chemical oxidation of organic matter with the help of storing the chemical oxidant. Next, useful in determining the strength of industrial waters in sewage, which cannot be determined by the biological oxygen demand test. So in some cases of BOD test, there is no possibility of calculating the oxygen content. But in this COD analysis, it is useful for determining the strength of industrial wastewater in the sewage. Next point, useful in determining performance and treatment efficiency of treatment methods. The COD analysis is useful in determining the performance and treatment efficiency. Of the treatment of the water. Next, what are the limitations of COD? It is having an inability to differentiate between biological oxidizable and biologically inert materials. So it is having some deficiency to differentiate what? The biological inert materials and also the oxidizable materials. So it is not having a proper clarity between the what are the agents which are biologically oxidizable and what are the elements which are biologically inert materials. And what the advantage is giving? COD determination takes only 3 hours. The good example, the best advantage of the COD is it is taking only 3 hours for the examination. The lab determination of COD uses a strong oxidant. So lab low, for checking the COD, they are using a strong oxidant such as potassium dichromate or potassium permanganate to stabilize the organic matter. Sewage water lo organic matter ni stabilize cheyadaniki they are using COD analysis or using in the laboratory some of the oxidant materials like potassium permanganate and potassium dichromate. Next one, known quantity of wastewater is mixed with a known quantity of standard solution. The known quantity of wastewater is mixed with the known quantity of standard solution of potassium dichromate and the mixture is heated. This organic matter is oxidized by K2Cr2O7 in the presence of H2SO4 hydraulic hydrosulfuric acid. So what is saying? How to do the lab experiment by using this potassium permanganate means the known quantity of wastewater is mixed. So we are measuring the wastewater quantity. For example, you are having 3 containers or 5 liters of wastewater with the known quantity of a standard solution of potassium dichromate is mixed. So these two, the wastewater as well as this strong oxidants are mixed and they are thoroughly heated. The organic matter oxidized by K2Cr2O7 is in the presence of H2SO4. The resulting K2Cr2O7 is treated and the oxygen used in the oxidizing the wastewater is determined. So by this treating of this oxidizing element with the wastewater, by heating it, the results are achieved. Thereby the oxygen content is determined by this process. So this process we are using it is taken by 3 hours to give the solution. Right? Next one. This gives the COD. This gives the chemical oxygen demand and is a measure of total organic matter. So what is the total organic matter? The biodegradable and non-biodegradable present in the sewage, right? Next, COD test is specifically more suitable to measure the organic matter present in the industrial waste having compounds of toxic to biological life. So generally, this water waste may be generally coming from industrial waste, domestic waste, and rainwater. So the COD is mainly used for or more suitably used to measure the organic matter present in the industrial waste. So majority chemicals ఎక్కువ when compared to the domestic water, industrial waste లో నుంచి ఎక్కువ chemicals release అవుతుంది కాబట్టి the chemical oxygen demand is most generally used for testing of industrial wastewater where they are having the toxic compounds, right? Many toxic compounds to the biological life. Next point. The COD results are generally higher than Bvod values. The results whatever you are getting in the COD are generally higher than that of the Bvod values. Since the test will oxidize the materials such as the fats and lignins which are slowly biodegradable, because since the test whatever you are conducting in COD analysis gives the results which are very slowly biodegradable. So slowly manaki decompose aye chances undi kabatti the values whatever you are showing in the chemical oxygen demands are higher than that of the biological oxygen demand. The next one is the total organic carbon, TOC. TOC refers to the total organic carbon. It is an important method of expressing the organic matter in the terms of carbon content. So here also this method is also used for testing the organic matter. It's also important thing for expressing or showing the results of organic matter in the terms of carbon content dwara it is showing. So the carbon is a primary constituent of organic matter. So organic matter ki the primary constituent is the carbon. Known concentrations of chemical compounds in wastewater. Known concentrations of chemical compounds in the wastewater will enable to theoretically calculate the carbon present in the per liter of solution. So the concentrations whatever you are having in the chemical compounds will enable theoretically to calculate the carbon present in the liter of solution. Next, biological oxygen demand. Next one is biochemical oxygen demand. This one is very useful. It is a measure of oxygen required to oxidize the organic matter through the action of microorganisms. So mundi case lo chemicals dwara we are testing the levels or measuring the oxygen demand, whereas in the biochemical test lo em chestunamante in order to check the oxygen required, so we are using the matter through the action of microorganisms. Microorganisms dwara we are testing the levels of organic matter, oxygen levels. Next point. directly gives the amount of biologically active organic matter present in the sewage. So what is giving? The result is giving that it is giving the amount. It is giving the amount of biologically active organic matter present in the sewage. Next one, the most widely used parameter. So among the BOD, among the COD, among the TOC, among the THOD, biological oxygen demand, biochemical oxygen demand is mostly widely used parameter for testing of the oxygen measures in the sewage water, mostly in the industrial sewage water. Then what's the definition of BOD? It is defined as the oxygen required for the microorganisms, the oxygen required for the microorganisms to carry out the biological decomposition, right? Biological decomposition of dissolved solids or organic matter in the wastewater under aerobic conditions at standard temperature. So simple define BOD and COD annappudu you have to write this definition. So Pvod is defined as the oxygen present required for the microorganisms. Okay, na? So the oxygen required for microorganisms to carry out biological decomposition of dissolved solids or organic matter in the wastewater under aerobic conditions at standard temperature. అర్థమైందా? So biological గా microorganisms ki oxygen kavali, right? For microorganisms we require oxygen. So in order to go for biological decomposition of dissolved solids in the wastewater under aerobic and oxygen aerobic conditions at standard temperature. So at standard temperature లో microorganisms కి oxygen కావాలి కాబట్టి for what oxygen? To carry out the biological decomposition of dissolved solids under aerobic conditions is nothing but biochemically oxygen demand, BOD. Next, the BOD test results used for the determination of what? Appropriate quantity of oxygen required for the biological stabilization of oxygen organic matter. So the appropriate quantity of oxygen required for the biological stabilization of organic matter. So what is the result it is getting? Used for determination of the quantity of oxygen present, the quantity of oxygen required for the biological stable avvadaniki organic matter ni we are using as a test. అర్థమవుతుంది కదా? So biological గా water stabilize అవ్వడానికి how much amount of quantity of oxygen is required? That is nothing but by using the test of Bvod. తర్వాత ఏం చేస్తాం? బయోలాజికల్ టెస్ట్ ద్వారా, biochemical test ద్వారా size of wastewater treatment facilities. It is also used for determination of the size of wastewater treatment facilities. Next one, the measurement of efficiency of treatment process. It is also used to measure the efficiency of the treatment processes. And the efficiency we are doing the treatment process is also used for measuring. Next one, the strength of sewage. So it is also used for checking the strength. So the strength of sewage. Next, the amount of clear water required for the efficient disposal of wastewater by dilution. So it is also used for determining the amount of clear water that is required for efficient disposal of wastewater by what process? Dilution method. Next, the BOD of water during 5 days at 20 degrees centigrade is generally taken as standard demand. So మనకి COD చేయడానికి we are requiring 3 hours. Here the water, the BOD of water takes during 5 days at 20 degrees centigrade is generally taken as a standard demand and about 68% of total demand, right? 10-day BOD is about 90% of total activity. 10-day demand is total about of 90% of total demand. So it is taking much time when compared to the COD, but if you see the differentiation, Bvod is giving the better results when compared to the COD. Next, how to see the Bvod and the chemical oxygen demand ratio. The COD will be greater than Bvod. Okay? The difference represents the quantum of non-biodegradable organics. So it is giving the difference why COD will be greater than Bvod means the representation of the non-biodegradable organics, it is showing the higher value. Next, BVod and COD will always be less than 1, but this value approach towards 1 with a decreasing amount of non-biodegradable organics. So whenever the ratio are taking Bvod by COD, it should be always less than 1, right? When it is always less than 1, we can decrease the amount of non-biodegradable organics. Next one. Pvod 5 is about 68% of Pvodu. So here we have said that it is taking the duration of 5 days. So Bvod is about 5 days, about 68% of biological oxygen demand unit. For fully biodegradable wastewater, Bvod 5 by COD ratio should vary between 0.63 to 0.68. So like we should be less than 1, right? It should be less than 1. So thereby what is the range it is having, the Bvod by COD ratio? The ratio should be ranges between 0.63 to 0.68. The next one is Bvod test. So in the direct method, we are having two methods of Bvod for testing of the oxygen levels. One is direct method, other one is a dilution method. So direct method so whereas in the dilution method, what are the steps involved means obtain the sample of wastewater, take the sample of wastewater in any beaker. Next, dilute the known volume of sample of wastewater with the known volume of aerated pure water. So once the sample is taken, initially the volume of wastewater with the volume of aerated pure water ni mix cheyandi. Third one, calculate the DO of the diluted sample. So calculate the values of how much amount of dissolved oxygen to this diluted sample. Fourth point, Andy. The diluted sample is then incubated for 5 days at 20 degrees. So once this is mixed, this sample should be stored, incubated and waiting, stored for 5 days at how much degrees? For 20 degrees. Fifth one, DO, dissolved oxygen of a diluted sample, after the period of incubation is calculated. Once the incubation time is over, that is 5 days at 20 degrees centigrade ayin tarvata, the dissolved oxygen sample ni we have to go for calculation. Therefore, the dissolved oxygen consumed is equals to the dissolved oxygen used is equals to initial dissolved oxygen minus final dissolved oxygen. Ante kada? So whatever the consumed, ela telusukuntamu dissolved oxygen ee sample lo consume ayindani ela telusukuntam. 5 days before manaki ఎంత ఉంది, 5 days తర్వాత ఎంత ఉంది, means initial DO minus final DO. Next, seventh point, Bvod 5 ppm is equals to dissolved oxygen consumed into dilution factor. So what is the dilution factor? That is nothing but dilution ratio. That is volume of diluted sample divided by volume of undiluted sewage sample. So how to take the ratio is volume of diluted sample divided by volume of undiluted sewage sample. So before diluted sample divided by the volume of undiluted sewage sample. Next. So like this, you have to carry the test for dilution method under Bvod test. Next one. What are the limitations? What are the limitations of Bvod test? So generally, this type of question you will get for 3 marks question, or it may be in the 4 marks or 6 marks question. Part A lo రావచ్చు, part B లో రావచ్చు. So part A లో ఎలా ఉంటుంది? State COD and Bvod test, లేదంటే state COD and Bvod అని రావచ్చు. Part B లో explain the features of Bvod with advantages and limitations, or explain COD and BOD analysis with an example. So like this also you can get a question. And what are the limitations of BOD here? First one is measure only biodegradable organics. So it is a limitation. So only this test is used for biodegradable organics only, not for inorganic matter. Second limitation is pre-treatment is needed if the sample contains toxic waste. So pre-treatment epudu use avutundi? Pre-treatment is needed if the sample contains what waste? Toxic waste. Right? Third one. Test uses an arbitrary long period of time to obtain the result. So the limitation enti? So it is taking very long time. Enta time teeskuntundi? It is taking about 5 days to get the result. So 5 days into long time kada. Next, fourth point. Effects of nitrifying bacteria should be reduced or eliminated by pre-treatment or by the use of inhibitory agents before the test is applied. So what is the fourth point? The nitrifying bacteria should be reduced. Ledante completely eliminate cheyali. There is a point. Next one. The 5-day BOD period may or may not be correspond to the point where the soluble organic matter presence has been used. So what is it saying? The 5-day BOD period may not be correspond to the point where the soluble organic matter present that has been used. So this is about the BOD introduction, BOD ratio, BOD test, and BOD limitations. Next, the inorganic matter. The following are the main inorganic matters in the concern in the wastewater treatment. So what are the inorganic fluorides? The nitrogen, the phosphorus, the municipal waste phosphorus, the toxic inorganic compounds like copper, silver, lead, chromium, arsenic, and boron, the heavy metals like nickels, manganese, lead, chromium, cadmium, zinc, copper, and iron, mercury, the gases like nitrogen, oxygen, carbon dioxide, carbon monoxide, right? Methane, hydrogen sulfide, like this. So in the next class, we'll discuss about the biological characteristics. These are some interesting things where you can get your school days things, the biological characteristics. Okay. Any doubts still here? If you have any doubts, just open your link, unlock your mic, and you can talk to me. So only very few were present today. Pavana Tulasi, Sheikh Abdul Wahab, Sudhakar, and Vinita. So hope this class is interesting, very useful for your subject point of view. So in detail, you are in the 4th year. So whatever the interview questions or whatever the topics you are interested, the person is asking interviewer which subject is very interested. And you have to say something among all the subjects what you have studied from 1st year to 4th year. So ఏ సబ్జెక్ట్ అయితే మీకు బాగా వింటారో, ఏ సబ్జెక్ట్ అయితే మీకు ఇంట్రెస్ట్గా ఉంటుందో దాని గురించి చెప్పడానికి మీకు ఎక్కువ స్కోప్ ఉంటుంది. దట్స్ వై choose the subject which you like most or which it creates liking. So then you can speak something about the subject. Understand? Right. So on a screenshot తీసుకోండి. So once the video is uploaded on the YouTube, I will forward this link to your WhatsApp group. Just open it, view it, like it, and send this link to other students, those who are not in this meeting. Group lo unna chustunnaru ledo teliyadu. Once you send personally with your friends, those who are having personal numbers, so that they can see and view it. Thanks for watching this 27th lecture. So we'll meet tomorrow's class. We'll meet in the tomorrow class. So tomorrow kuda morning session untundi by 9-10. Come to the class on the time.